Hi guys, BuildZoid here, and today we're going to be taking a look at another GPU PCB, this time the Zotac RTX 3070 Ti Amp Extreme Holo Edition. I think there's edition in the name, I don't remember. Either way, yeah, Zotac RTX 3070 Ti custom PCB, and the PCB pictures are from Tech PowerUp's review of this card, so if you'd like more details about it, like thermals, noise, performance, power consumption, you should check out the review of this card from Tech PowerUp. And also thank you to them for providing high-res PCB pictures in their reviews. There will be a link to it down in the description below. And with that out of the way, let's get into it. So, Zotac is a strange GPU manufacturer. They've been around for ages, but I can't say I've ever really liked their high-end cards very much. Well, around the 500 series, they made some cool stuff, but basically, I don't like their 3090, I don't like their 2080 Ti, I don't like their 1080 Ti, and I really don't like their 980 Ti. So, you know, and I don't know what their 780 Ti looks like, but if I had to guess, I probably don't like that either. So, it's kind of funny that with most manufacturers, you get it the other way around. You get really nice, like, flagship cards, and then the rest of the lineup is kind of not necessarily that great. And then we have Zotac, where it's like, I consistently dislike their flagship cards, but then they come out with a 3070 Ti that looks like this, and I really like what they've done here. Like, this thing is freaking awesome. This has to be, like, the best 3070 Ti PCB I've seen. Now, it is a bit brute force in its approach, so I'd actually really like to see oscilloscope measurements comparing, like, this card to a Strix 3070 Ti, not even the Founders Edition, because the Founders Edition, like, NVIDIA, and the funny thing is, yeah, like, I don't consider the Founders Editions particularly amazing. Like, basically for if you get lucky, Galax puts out a Hall of Fame edition, and otherwise you sort of have to go with like an Asus Strix card a lot of the time to see the best possible PCB configuration for, you know, NVIDIA GPUs. So, yeah, so I'd love to see a comparison of this against a 3070 Ti Strix, but just the fact that I'm even considering a comparison of that is already, like, that is quite the achievement, because normally I wouldn't consider, like, any Zotac card to be even in, like, the same neighborhood as a Strix card. So, let's get into it. For one thing, they've rotated the core, and I suspect this hole spacing actually matches a RTX 3090. So if you have an RTX 3090 compatible LN2 pot, you could actually mount it onto this, which is not possible with the vast majority of 3060 Ti's, 3070s, or 3070 Ti's, because those all have, I think, probably the same actual hole mounting pattern, except it's 90 degrees off, right? Like, normally your memory chips are like this. On a 3070 or a 3060 Ti or a 3070 Ti. And so the whole spacing is also 90 degrees rotated, and no LN2 pots fit that, as far as I'm aware. Like, that's just not a thing that's supported. So you might actually be able to get an LN2 pot on this, and so for that alone, I'm already kind of impressed. Like, I'm already kind of a fan of this card, but I'd like to confirm that, and I kind of suspect that these capacitors might be a little bit too close to over here, so that might cause some, like, LN2 pot mounting conflicts, but other than that, like, yeah, the core rotation and the fact that this really does seem to be using 3090 mounting hole spacing, it's like, that's cool. And then we get to the sort of the star of the show, which is the Core Vrm, which kind of benefits from this core rotation because it allows Zotac to route the power plane sort of like this. Though it's oddly enough, the 3070 Ti Founders Edition actually just sort of has the power plane go, like, they have a part of the Core Vrm, like, over here, and then the rest of the Core Vrm over here on the reference design. So I really wonder, like, well, no, I don't wonder. They have to be running a power, like, the Founders Edition has to be running a power plane under the memory chips, which I have my doubts about how optimal that is, but I guess if you have a high enough layer count, that's not necessarily an issue. Yeah, anyways, this layout seems a bit more sensible, you know? It really, because you can just sort of run the power planes like this, though admittedly this does kind of increase the distance, even if it does mean you don't actually have to run power planes directly under the memory chips or too much under the memory chips. I would assume they're probably still putting a power plane that goes like that, but, you know, yeah, I don't have actual schematics for the board, so I don't know exactly how everything is laid out, but And this seems a bit less awkward than what you have on, say, a 3070 Ti Strix or a 3070 Ti Founders Edition. And that's thanks to the core rotation. So anyway, yeah, the V-Core VRM on this is a monstrosity. It's absolutely gigantic. And I guess it kind of benefits from the same idea that you have on like 3080s and 3090s, where it's like, well, if you push power from two sides into the core, you effectively have a wider power plane because you're not shoving it all in from one side. Though that also heavily depends on how the actual BGA of the core, like of the chip, is configured. So, you know, again, like this is super hard to judge without actual schematics, but what you don't need schematics for is to realize that there is so many damn power stages. So these two rows of V-Core power stages and inductors make up give us a 16, and it's DRMOS components, well, they're not that dumb. They have a thermal warning system, they just don't have any current monitoring. Either way, 16 DR-MOS for V-Core, and I'm doing that wrong, and the DR is for driver, it's not for doctor. Just fun fact, it's not doctor. It's just because there's a driver integrated with some MOSFETs. So 16 DR-MOS V-Core, which is absolutely huge. That is straight up the largest V-Core VRM on any 3070 Ti. By a very large margin. The Founders Edition, for comparison, is 9 phases. So this thing is, yeah, absolutely gigantic. And it is controlled by this chip right over here, which this is a UP 9512. And this is why I sort of consider this card to be a little bit of a brute force approach to the take on a 3070 Ti PCB, because the 9512 is not the best voltage controller that you could stick onto a 3070 Ti. That would be the monolithic Power Systems MP2888, but I would assume the MP2888 is also several times more expensive than the 9512, so it really isn't that surprising that Zotac isn't using it. And also, it doesn't, like, just because you're using a more high-end controller doesn't necessarily mean you have it configured correctly to really take advantage of its potentially better performance. And anyway, so 9512, 8-phase controller, up to, I believe, 1.2 megahertz switching frequency, and some basic digital control functionality. So you can adjust, like, there's a voltage offset function, if I remember correctly. There's some load line settings available, though I think they might be overridden in hardware. You can adjust the switching frequency. I think you can change the phase shed. Well, there should be phase shedding controls, but I don't know why you'd want to do anything other than, like, have all the phases running all the time. So, yeah, either way, 9512, not the cheapest chip that you can get on a 3070 Ti for V-Core, but also not, like, the greatest. Again, the MP2888 exists. But yeah, Zotac is taking all 8 of those phases from that 9512 and just sort of taking each PWM signal and mashing it into 2 power stages at the same time. Probably something like this. And so that gives us a, 16 DR-MOS, 8-phase V-Core VRM monstrosity that ends up with an absolutely stupid amount of current handling capacity, because these DR-MOS components are, of course, Alpha and Omega Semiconductor AOZ 5311NQIs, and these are sort of the default power stage for a lot of NVIDIA, like 30 series NVIDIA cards. These are 55 amp DR-MOS components nominally. Fun fact, when they were first released, the documentation had them at 50 amps nominal current output. Now they're 55, but they didn't change the efficiency curves, so I don't know why they bothered, like I really don't know why they got up, like, the documentation got updated to a 55 amp nominal current, because you shouldn't be averaging 50 amps through these anyway. Like, the efficiency curves end at 40 amps, because past 40 amps, the efficiency is so bad that while, yes, technically, if you have enough cooling, you can run 55 amps through one of these, practically speaking, you never want to do that. But anyway, that doesn't change the fact that, like, these are sort of the generic generic DR-MOS for 30 series and like NVIDIA cards. And as I mentioned, The Founders Edition, for comparison, only has 9 power stages, whereas this has 16 of them. And the Founders Edition is also on something either exactly these same parts or very similar parts. So and also the Founders Edition is also on a UP9512. So it's not like Zotac is going below what like NVIDIA would give you. No. This is a very direct upgrade over what NVIDIA would give you. But I don't consider NVIDIA to be, like, offering a better PCB quality than NVIDIA is, in my opinion, a very low bar, with maybe the exception of the 3080 and the 3090 Founders Editions. But I feel like that's mostly down to the reference design spec being extremely awful rather than the Founders Editions being particularly amazing. Anyway, yeah, so Zotac just went to town on this Core Vrm with arguably way too many 55 amp power stages. I mean, DRMOS components doesn't really make a difference. The difference between a power stage and DRMOS components is that normally power stages integrate some extra functionality like current monitoring and somewhat better temperature monitoring and, you know, like extra features, whereas DRMOS components don't integrate. Like, these have a thermal warning system. They don't have a temperature monitoring system. They don't have a current monitoring system. I'm pretty sure they don't. We can check that. Oh, actually, we can't. No, they don't. You can see it right here. There's your DCR current sensing. Bam. So they got plenty of layers then, because we can't see it on this side. Or maybe, yeah, we can't see it on. No, you can just about make it out there. And then on this set of this set of phases, it's, I guess, a layer down or two, and so we can't see that part of it. But anyway, yeah, so they don't have like built-in current monitoring or anything like that. They're really just a driver and 2 MOSFETs and some basic thermal protection. But anyway, that doesn't change the fact that this VRM can handle a stupid amount of current. Like, there's 16 power stages, right? Like, that's kind of the whole point of having 16 power stages. So at 1 volt output, 500 kilohertz switching frequency, this VRM should be able to output 160 amps while producing about 14 watts of heat on the power stages. That's not accounting for, you know, like the power plane losses and the inductor losses. Actually, I might have to, well, the thing is the documentation, okay, you know what? I forgot to check this. So I am just going to very quickly check the data sheet for these because I can't remember if alpha specs with or without inductor losses, because some manufacturers do and some don't, and that is really annoying. So, oh, they don't mention. Lovely. Okay, well, that explains why my notes don't include anything about that. So the documentation doesn't mention if this includes inductor losses or not. So I'm just going to go with like just the power stages. Ultimately, the inductors don't really lose that much power anyway. That's sort of like, they don't really, like the inductors don't really lose, like they're basically just a bit of wire. There's not much power loss in them. But either way, like this is really great efficiency. Like even if we're just talking power stage power losses, like that is very great. Like that's very good efficiency right there. And then at 240 amps, and this is before the peak of the efficiency curve, by the way. 240 amps, this VRM should only produce about 20 watts of heat on the power stages. And then 320 amps, it'll produce only about 30 watts of heat. So now we're sort of in the falling side of the efficiency curve. 400 amps output, it'll produce about 44 watts of heat. And 480 amps output, it'll produce about 62 watts of heat. So, like, this is the cool thing about this VRM is that this is roughly about as much current as you'd be averaging on a like unlimited power 3070 Ti. Like you're not gonna, like in day-to-day usage, you're gonna be sort of more like kind of between these two values, but more towards that 240 amps. And so this VRM is like insanely overkill for for a 3070 Ti. And really, if you wanted to do extreme overclocking with the 3070 Ti for some reason, this is sort of the perfect card to do that with, because the VRM is really not going to have any issues with it. And for comparison, like you can get 3070 Ti's with like half of this VRM. Literally half. Like same power stages, but half as many of them. And so, you know, like, yeah, I'm a big fan of what Zotac has done here. And basically, like, half this VRM is, you would be basically, instead of looking at like this level of efficiency, you'd be looking at this, but divided by 2. So you'd be getting like 240 amps producing about 31 watts of heat, which this is kind of a lot of heat for just 8 power stages, because that works out to, what, almost 4 watts of heat per power stage, which is a lot of heat. You know, like, it's very easy to handle about up to around 2 watts of heat per power stage is very easy to deal with. And then much more than that is kind of like you start needing steadily larger and more elaborate heat sinks. Though GPUs do have a significant advantage over motherboards when it comes to VRM cooling, in that GPUs come with fans. I know, it's incredible what airflow can do. So GPUs can generally get away with much worse VRM efficiency than like motherboards can, because motherboards kind of have to rely on people to have, you know, some kind of airflow around probably the most airflow-starved area of any system. Like, the VRM area of a motherboard is basically a dead zone, because you're behind the CPU, and if you have, like, a water cooling system, you know, yeah, like, you're in sort of the exhaust area of the case, but all the fans, like, the rear exhaust fan is, like, directly above the heatsinks, so it's not going to really be pulling air over the VRM heatsinks. It's going to be, you know, like, like, yeah. So anyway, so generally speaking, GPUs can actually get away with worse VRM efficiency than this, which is why, like, so many 3070 Ti's and 3070s use, like, way fewer power stages than this does. But yeah, if you wanted to do extreme overclocking, this is kind of the perfect VRM to do that with, because it has more than enough power to, like, more than enough power handling capacity to do that. So that's cool. So yeah, that's kind of the highlight of this card, is this is a hell of a lot of V-Core VRM attached to a 90-degree rotated 3070 Ti, and then the rest of the card is very sort of standard 3070 Ti things, like, say, the memory VRM, which is just a 2-phase, which is the norm. Like, this is a pretty standard 2-phase memory VRM for a 3070 Ti. You've got a high-side MOSFET, you got a low-side MOSFET, and another high-side MOSFET, and a low-side MOSFET. The high-side MOSFET is a QN3103 from Ubix Semiconductor, and that's a M6N variant. Actually, I don't think they have any other variants of the 3103, but I think it's the 3106, where there's like an M5N or an M3N and an M6N version. Anyway, it doesn't apply to this card. And then there's the 31, they have a QN3109 M6N for the low side. And the low side MOSFET here is 1.62 milliohms, which is very low RDS on, but also in line with what you'd normally expect to see on a 3070 Ti. Most 3070 Ti's use low side MOSFETs that are somewhere below 2 milliohms of RDS on. So this is not the worst low side MOSFETs I've seen, but they're not particularly amazing. Like, they're not, like, actually, it's a really low RDS on MOSFET in general, but the thing is, this is kind of the norm for the low, like, for the MOSFETs in a low side, well, for the low side of a memory VRM of a 3070 Ti. This is just kind of what you'd expect to see here. So yeah, like, that's a very low RDS on low side MOSFET, but at the same time, it's also kind of like, well, the norm for 3070 Ti's. The GDDR5X is, I mean, GDDR6X is quite power hungry. And then you get the QN3103, which is the high side MOSFET, and that has 6.3 milliohms of RDS on, which is really quite high, but it's a high side MOSFET, so it really doesn't have to handle that much current, and so the RDS on isn't that important as the switching times are. And because I can't, like, the thing is, you're not going to have a memory power delivery issue with this. Like, this is the norm. I can't be bothered to do the math, so I haven't done the math. We're not doing efficiency figures for the memory VRM. I don't care. So anyway, yeah, pretty standard memory VRM controlled by a UP1666, which is right over here. And the UP1666 is kind of neat because it's very, very easy to volt mod. So if you want to add, like, if you want to raise or lower the memory voltage, you can look up the UPI Semiconductor UP1666 documentation, and then, like, very, very easy to get voltage control on this chip. And yeah, that's just a 2-phase memory VRM controller. Like, that's all, like, yeah, I would assume somebody somewhere has used it for something else other than memory power, but I've only ever seen it used for memory power on NVIDIA GPUs. So memory VRM controller it is. Anyway, so that's kind of the power capacity side of the equation. We have a lot of like a very, very powerful Core VRM and then a two-phase memory VRM that's kind of in line with what you'd expect to see on any 3070 Ti. The card also does have a bunch of power connectors, but I question how useful that actually is. Oh, and then you have your shunt resistors, and I guess with monitoring chips, you've got a US 5650 there. So that's from UPI Semiconductor. There's no document. I've not seen a public document for that one yet. Though I've not looked very hard recently. I like when that chip first started showing up, I checked, couldn't find it, and I haven't checked since. So I don't know. Maybe these days you can actually get documentation for it. And we don't have a second one. That's interesting. Because, okay, well, actually, that's not interesting. That makes sense. Like some NVIDIA cards have like two US 5650s, which is really weird because a US 5650 is a 4-channel shunt monitor. So this chip can monitor 4 different shunt resistors, and this GPU has 4 different shunt resistors because it's got 4 power inputs, which, you've got 1 shunt for the PCIe slot, then you've got your 1 shunt per power connector, and then you've got your 4 shunt monitoring chip, and that's sensible. But the funny thing is, there's a lot of, like, other NVIDIA GPUs where you only have 4 power connectors, but for some reason 2 US 5650s, and 8 shunt resistors, which is very concerning from the perspective of, like, why? Like, why do you need that many shunt resistors when you've only got 4 power inputs? Anyway, so yeah, that's what's going on with the power monitoring. There's no protection fuses on this board whatsoever for like limiting so basically if something goes wrong on this board, there's no fuses to save the day, which is not really like that's the norm. Like the vast majority of GPU manufacturers don't bother with any kind of protection fuses on their GPUs. There are some exceptions, but so like the thing with the fuses is they're really nice if if something goes wrong on the card, they can make repairing the GPU a lot easier. At the same time, they don't the fuses don't prevent the card from failing in the first place. Like the fuses are there to minimize damage after a failure occurs. So the lack of fuses is kind of like, yep, that's the norm for, GPUs, regardless of how high end they are. Yeah, I figured I'd point that out because, well, as I've been getting into buying more and more cards off of eBay to try repair them, I've kind of realized, you know what, those fuses are really handy. Like, sure, they don't prevent the power stage from blowing up in the first place, but when it blows up, it prevents it from putting a crater in the PCB sometimes. So, yeah, those would have been a, nice inclusion in my opinion. And also, if you're an extreme overclocker and you're worried about blowing the fuses just as a part of an extreme overclock, you could just short them, right? Like that's the thing is, if you don't want the protection features, you can just disable them. And if you're a regular user, well, they don't really help you when they don't help with protecting the card from failure. They help with making it easier to fix the card once a failure occurs. So anyway, yeah, so I figured I'd just point that out, that this card does not include any protection fuses. And then, what else do we have here? Right, we've got the minor rails, which this right here should be 5 volts, and then one of these is going to be PEX, and one of these is going to be 1.8 volts. I don't know which is which, and I'm not going to take a guess. We do have voltage read points on this card, but they're not labeled. And the only reason I figured out these are voltage read points is because you can very clearly see this trace. So that's that's VCore right there. This looks like it's probably 1.8 volts. This is memory. This I have no idea. I have no idea. I have no idea. Like I would assume there's like a 5 volt, 1.8 volts PEX, and probably even a 12 volt voltage read point up there. But yeah, they're not labeled. So if you get the card, you can figure out how they're wired up. And it's worth noting that these are not going to give you very accurate voltage readings because, look at where this voltage read point is connected to. it is connected to this corner of the vCore power plane. This is where the core is. This is where that voltage, like if you're measuring the voltage, you'll be measuring it from over here. There is going to be a significant voltage drop over the power plane under load if you're measuring from here compared to if you were measuring like behind the GPU core. So this is more for like indicating that the card has core voltage. And if you have a volt mod, you can check if the core voltage is going up or if it's going down, but it is not an accurate way of measuring what the core voltage actually is because you're measuring it like way far away from the GPU core. Whereas the actual voltage controller, the UP9512, this will have a 2-wire connection directly to a voltage read point on the BGA of the chip, which will be far more like so. So let's say you set the 9512 to output 1.2 volts. Well, with all probability, your measurement over here is going to be off by 30 millivolts, 50 millivolts, maybe more than that. I don't know. You'd have to actually test the card to figure that out. But yeah, it's very unlikely that this will be anywhere near the actual core voltage unless this power plane is like unless there's many layers of vCore power plane that we can't see here, which I kind of doubt because you've got memory chips, and memory chips kind of need, somewhere to run their data lines, as well as have their own power distribution and reference planes. So anyway, yeah, we've got voltage read points. It looks like at some point in time they were considering adding a dual BIOS switch and then just didn't bother to do that. And now we get on to the back of the card where I love what they've done with the capacitor configuration. Well, okay, no, I like what they've done with the capacitor configuration. So we have the typical Zotac cover plate that this tries really hard to imitate a prodlizer. It's not actually a prodlizer. What's going on is there's a bunch of probably these just under that. And it's not and I say probably these, I know for a fact that there's just, molded polymer capacitors under that cover plate. However, I'm not sure what exact molded polymer capacitors are under that. And I'm not necessarily, I would have probably appreciated that being closer to the core, though. I guess there's not really anywhere else they could have really put it. Yeah, but what I do like is that they've added all of these extra polymers for, I'm assuming those are for memory power. Yeah, because these are basically sitting right behind the memory chips, so that could help with memory overclocking. By tens to maybe 100 megahertz, maybe. Actually, 100 megahertz would be a lot. 50 megahertz would be sort of impressive for a improvement due to the capacitor configuration, though it depends on how bad it is on other cards. And so on average, I would expect this card to be better at memory overclocking because it really does seem to have a better memory power filtering system. So I think that's really neat. The core power delivery, I mean, directly behind the core, we've got the standard configuration of polymers, which, isn't too surprising. It looks like Zotac has decided to populate a lot of the optional capacitors that you wouldn't necessarily see on, well, even the Founders Edition. A lot of 3070 Ti's, they just don't bother with these little 0402s, but Zotac has decided to include those, so that's cool. That might help a little bit with core overclocking. We've got this over here, which they've not populated properly, which is a bit unfortunate. And then for the bulk capacitance of the vCore VRM, this is, so I really like what they did with the memory, but the core is kind of just I mean, these are 1200 microfarads, so they do have a lot of capacitance, but they're through-hole capacitors, so they've got way more ESL than your, molded polymer capacitors. And I don't actually know how many they fit under these cover plates. I think it's 6. I think they have some arrangement that's basically something like this. Or actually, that might not even fit. It might just be 4. It might just be like that. Yeah. Anyway, so I would have preferred to see more molded polymer capacitors in the vCore output filtering. But even then, compared to most 3070 Ti's, this is actually really cool. What they've done in terms of the power filtering with the capacitors. So, yeah, I'd love to see this card like under an oscilloscope, you know, for V-core and for memory power, and like a comparison between this and say a 3070 Ti Strix and potentially a Founders Edition to give you some idea of like what NVIDIA thinks is appropriate for power delivery on a 3070 Ti. Because I think a lot of people would find that quite shocking compared to what you see on like AMD GPUs for comparison. Or older NVIDIA cards as well probably do a better job. Anyway, yeah, so that is the Zotac RTX 3070 Ti Amp Extreme Holo. A huge V-Core VRM, extremely powerful. The capacitor configuration here is kind of like, eh. Well, actually, no. The memory configuration is really cool. The core configuration is kind of like, eh. Yeah, it's just kind of eh. It's mostly through-hole capacitors, and I really think, like, instead of the silly power boost cover plate, they should have just, like, put polymers. You know, actually, they could have just moved the V-Core VRM closer to the core, for one thing. Could have shortened the card a bit by doing that. Could have populated this fully, right? Like, they added all these extra like, I think these are extra. I don't think these are, like, some spec from NVIDIA that you're supposed to have this. So they could have populated this since they added that. But the thing is, like, Zotac has this whole thing where they put, like, a cutout in their backplate for their silly power boost cover plates, and it's just kind of like... So this is, like, more a marketing gimmick than an actual, like, useful... Like, there are still capacitors under that, and they are molded polymers, and those are better than through-hole polymers, but it would be better if we just had more molded through-hole, more, you know, SMD polymers. Instead of the cover plate. So yeah, but that's what they did with the memory. Like with the memory, they really went really far on that. So that's cool. And then in terms of power handling capacity, this card just looks, you know, epic. So yeah, I rather like this. This is like, I would probably still mess around with you know, upgrading the capacitor configuration. They also had like all these mounts for multi-layer ceramics that they decided not to bother populating, which I don't know how much of a difference they would have made. Probably not much, but you know, if you were really pushing the, like if you actually decided to run like LN2 on a 3070 Ti like this, like they have the space here, especially to do something similar to like a 3090 Hall of Fame. Right, where Galax basically, and like Galax has my favorite VRM output filters because they basically just, every millimeter of extra space on the V-Core power plane is just used to cram more capacitance. So on Galax, like if this was a Galax card, you'd have your, you know, big through-hole polymers. Then I'd expect a mix of ceramics and molded SMD polymers in front of that. And well, this doesn't have that. This just has a bunch of empty space so that Zotac could cram that power boost cover plate where they did. So yeah, still though, it's not like you can get a 3070 Ti Hall of Fame, and so, you know, this doesn't really have a lot of competition when it comes to like 3070 Ti's in terms of power delivery. So this could still be really, really, really great. And I'd love to see oscilloscope shots of this compared to other 3070 Ti's. So yeah, that's the Zotac RTX 3070 Ti Holo Amp Extreme Holo. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. Both the Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you'd check them out. And also, the PCB pictures for this video are from Tech Power Up's review of the card. There's a link to their review of it down in the description below as well. And that is it for the video, so thank you for watching, and goodbye.